Okay. This is the tutorial for the first part of your Mythbusters final lab project. Okay. Uh, so I mentioned this before, but most of your college career, you all have been doing everybody else's experiments, right? There's a teacher or some lab book that decides what are the important things you should be knowing about your field, right? But I think one of the things that is super missing, especially for people that are going to one day go into research, is that it's it's so rare that students know how to design their own experiments, right? To have a question and be able to test it in a scientific way using the scientific method in a very thoughtful way that makes sure that you're actually getting the answer that you're to the question you're asking. Okay, so this is that project. So you're going to take something that you're just curious about, and I want to try to be as authentic as possible about this, right? What is it that you are curious about in the world? It's obviously has to be something that's testable. It can't be something crazy like, does alien life exist? We don't have the capacity to test that in this class, but something smaller like um, does breakfast cereal actually have iron? Does soda really rot tooth enamel? Um, can you actually make an LED light up with a potato or a lemon? Okay. How many balloons would it take to lift a house? These are kind of interesting questions, right? That are very testable um, in our environment if we ask the right questions and design the lab the right way. Okay. So just a reminder about what the scientific method is. First part of the scientific method is to ask a question. Okay. So let's say the question is, can you really make an electromagnet by wrapping turns of wire around a metal core? And will it actually be strong enough to pick up objects? Hypothesis. Generally, try to focus on one question though. Um, Maybe if there's a secondary question and it's a really good secondary question and you feel confident about your lab, you can ask another one. But try to focus on one good question. So two with the hypothesis. Okay, the more turns of wire, the stronger my magnetic field will be. All right, that's an interesting hypothesis for that question. Um, Experiment. Now we can adjust the number of turns of an electromagnet and see how many of something it could pick up. Like let's say paper clips, right? If we have more turns, picks up more paper clips, that is evidence that our hypothesis is correct, right? Um, we need to, for the scientific method, you need to do an analysis, right? So once you have your data, you need to create tables and graphs that visually represent the relationships between the turns of the wire and the strength of the magnet. Obviously, this example is just for this one experiment. You'll all have your own hypothesis, experiment, and analysis. Um, and then finally, you have a conclusion, right? Yes, there is a direct relationship between the number of turns in the electromagnet and the strength of the magnetic field. Okay. Now, over here, I showed you that there is some sample myths you can take, and I would like you all, with you alone or with your lab partner, to pick three uh, myths that you're curious about, right? So that you can at least narrow this down to three that you might want to do, and then you can talk to your lab partner about it and decide on one final one. Okay, so what is the process, right? So how does it work from here? Once we have a question, we pick one of the questions, and you can go ahead and write it down right here. What is your question, right? Um, and let's go ahead and go with can you actually create an electromagnet from a wire, a nail, and um, a, a battery? Okay, so craft your hypothesis. You know, make a guess, make an educated guess about what you expect is going to happen. Then you have to design your experiment. A couple important things to design your experiment. First of all, you're going to have some independent variable, right? Um, these are the factors or conditions that you actually manipulate. So in this example, it would be the number of turns, right? You are changing the number of turns. Um, and we say independent because it's not dependent on anything. You're controlling it, right? Whereas the dependent variable would be how many things, how many paper clips that magnet could then pick up, right? So in other words, the number of paper clips that you can pick up should depend on the independent variable, the number of loops around the nail, okay? So remember, independent variable is the thing you change. Dependent variable is usually the thing that you measure, all right? Because the thing that you change affects, or the dependent variable is dependent upon the independent variable. So there's extraneous variables, and these are extra factors that may influence the outcome of the experiment, even though it's not the focus of the experiment. Ideally, these variables won't affect the conclusions, but some will. So as best as possible, you want to control for your extraneous variables, right? So for example, when you're doing this experiment, don't change what you're wrapping the wire around, right? Maybe what you wrap the wire around, whether it's a nail, whether it's a railroad spike, whether it's a another magnet, right? Whatever you're wrapping the wire around should not change. So that would be a control. That's something you're keeping the same through the entire experiment. Okay. Another thing that you want to keep as a control for this experiment would be the voltage of the battery, right? If we're really only measuring the number, or how the number of turns affects the strength of the magnet, then we don't want to change the strength of the battery because that could affect the experiment. Hint, it actually would affect the experiment. All right, so then you want to answer these questions. In your experiment, what are your independent variables, right? In your experiment, what are your dependent variables? And what are you going to control for? So in the case of the electromagnet, your independent variable would be the number of turns. Your dependent variable would be the strength of the magnetic field, or the number of paper clips that the magnet could pick up. And the control variable would be what you're wrapping the wire around, and also the strength of the battery. Okay, so then you want to create a procedure for your experiment. And this is important. It has to be very, very clear. Students most often lose points here because their procedure isn't clear, but your procedure has to be so clear that someone who's not you, like your little brother or sister, could follow these directions and be able to complete your experiment. All right? Okay. Now, I'm mostly expecting that you folks will be able to use materials that you can obtain at your house, or purchase fairly cheaply. But if not, if you do think of something that's necessary for your experiment that we might have in the stock room, or that we could order for you, as long as it's not crazy expensive, you can write that here too and let us know. Okay. And yeah, now that you have your variables that you're going to be measuring, create the table below, and you could do this in Excel or by hand. What is the table going to look like in which you're going to collect your data? All right. Make sure that you're using the right units. If there's more than one table, use more than one table. And just make sure that this is exactly everything you need in order to fill in your data for the experiment, and then subsequently be able to graph it, because next you're going to have to graph it. Here it says, in this section of the experiment, you will design some visual representation. So are you going to make a graph? Are you going to make a chart? Are you going to make an infographic? Is it going to be a pie chart? Is it going to be a scatter plot with a trend line? For most of you, it'll probably be a scatter plot with a trend line, but there may be exceptions to that. And finally, you're not going to be able to answer this yet, but given your data and analysis, was your question confirmed, or your myth confirmed or busted? So you don't have to put anything here yet, because you won't know until you actually complete the experiment. But that's basically what we're doing here. We're designing an experiment, and be as thoughtful as possible. Okay, as thoughtful as possible. Think through all of this, what you have to control, because now over the next 2 weeks, I'm going to have to be analyzing your experiment, and if it doesn't hold up, I have to send you back my critique, and you have to adjust it. So the goal is, as much as possible, create an airtight experiment now, so that the amount that I ask you to change is the least. It's the least amount of work for both of us. All right, that's it. If you have any questions, obviously reach out. Good luck, everyone.